Hi, welcome back. This is Rakesh Naik. Today we are going to discuss about yet another application of dynamic programming, that is all pair shortest path by using Warshall-Floyd algorithm. But before we start, a small information I'd like to share. In this channel, we produce every video in 2 different languages. If you want to watch this video in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, please subscribe and press the bell icon so that you will get regular updates from this channel. So, let us start. The objective of all pair shortest path problem is to determine the matrix A such that Aij is shortest path from vertex I to vertex j. By now we have learned about a single source shortest path, in which from one single vertex to all other vertices, what is the shortest path we found? That is Dijkstra's algorithm. But here we are going to learn, if we will take any pair of vertices, even though there is not a directed edge, still then we'll be able to find a path which is supposed to be shortest. Let us see the assumptions, because without assumption if we'll start, maybe we'll stuck somewhere. The shortest path from I to j, where I is not equal to j, passes through some intermediate vertices. If there is no direct edge from I to j, we have to find a path from I to j via some intermediate vertex. And if let us say k is the intermediate vertex, the shortest path from I to j consists of a path from I to k and then from k to j. And to make the path I to j shortest, I to k supposed to be the shortest path and k to j supposed to be shortest path. Otherwise, I to j will never be a shortest path. So this is the basic assumptions that we are having before we start all pair shortest path. There is one more question here. Why I is not equal to j? If I equal to j, then what happens? If I is equal to j, then traveling from one vertex to the same vertex. So always we consider it to be 0. We are going to use this formula to find all pair shortest path. The detail about this formula we'll be able to learn while doing the example. Now let us take this example. Here there are 5 vertices and there are some directed edges. Now we'll be representing this graph with the help of an adjacency matrix. What is an adjacency matrix? When there is an edge from I to j and the cost is Cij, then I'll write the cost Cij in the matrix having I to j. Otherwise, if there is no direct edge, I'll write infinity. So here is the adjacency matrix. From vertex 1 to vertex 2, there is a directed edge with value 3. So from 1 to 2, we have written 3. Similarly, all other edges also we have represented. And whenever there is no direct edge, we have written infinity. The first step what we are going to do here is the cost matrix or the adjacency matrix that we got, we'll write as matrix A0. Now we are going to find A1 by using A0. We are going to use this particular formula. Now by using A0, we are going to find A1. It means we are going to assume that all my path from vertex I to vertex j will move through vertex 1. The intermediate vertex will be 1 here. It means the path from vertex I to 1 and then from 1 to j will find its cost and the original cost. Whichever is smallest, we are going to take it. Let us see. The first thing what we are going to do is we'll take the first row and first column as it is. So this is the first row and first column. We are going to write it here. The next step is the diagonal, all zeros, we are going to write here as it is. So we have written here. The next step is wherever we are having infinity, so that particular column I am going to write. The next row is this particular row. So the rest of the value also I am going to copy. The next row is this one. I am going to copy this row also. At the same time, you can see the fourth column also having infinity. I have to copy it, but then we have already having all the values copied here. Now we are going to find the value in the blank spaces. Now you see I am going to find the value of, now in A0 matrix, 2, 4 value, and as I have already told you that it is that the path supposed to pass through vertex 1, then 4, 1 and 1, 2. According to this formula we are going to write. Now locate the location. This is the value that we are going to find. Originally it is infinity. And the value which is in green, I am going to take this. It means sum of these two or the original value, whichever is smaller. Here the smallest value is sum of these two, that is 5. I am going to write it here. Next value I am going to find is 4, 3. 4, 3 original value is -5 and its projected value to the fixed row and fixed column is 2 and 8. The sum of these two is 10 and -5. I am going to take the smallest. So -5 is smallest. I am going to write here. The next empty space is 4, 5. Now in 4, 5, the location I am having infinity. And if I project it here, I will get 2. And if I project it to the fixed row, I am going to get -4. So -4 plus 2 and infinity. Which one is smallest? So I am getting the value minus and I am going to write it here. Now I got all the values of A1. Now I am going to use A1 and find the value of A2. Here what I am going to do? I am going to keep the second row and second column fixed or unchanged. It means what? All my paths supposed to pass through the second vertex. So here the second row and second column, I am going to write it as it is. Now the next thing is the diagonal supposed to be unchanged. I am going to write the diagonal as it is. And in this particular fixed row and fixed column, I am having here in the first column infinity is there, third column infinity is there, and in fifth row infinity is there. So I am going to write them as it is. So I got this particular table with some blank spaces. So what I am going to do? I am going to take the values from this fixed row and fixed column and try to find the value of the empty cell. So the empty cell is 1, 4. Now originally I am having 1, 4 as infinity. So what I am going to do? I am going to project this cell to this fixed row and this fixed column. Sum of 3 plus 1 and infinity. Which one is smallest? I am getting 4. So I will write it here. The next empty space is this one. First row, fifth column. In that I am having -4. And if I project the value to the fixed row and fixed column, I am getting 7 and 3. The sum of these two is 10 and -4. I am going to take the smallest. So the value I got is -4. The next value that I am going to find is 3, 4. And in 3, 4, the value I am having is infinity. And if I am going to project it here, I am getting 1 and 4. The sum of these two is 5. So I am going to write here 5. The next empty space I am having is 3, 5. And in 3, 5 location, I am having infinity. And if I project it to the fixed row and fixed column, I am getting 7 and 4. The sum of these two and infinity. Which one is smallest? So I am going to write here 11. And the next cell which is empty is 4, 5. The 4, 5 location I am having -2. And if I project it to the fixed row and fixed column, I am getting 5 and 7. The sum of these two is 11 and -2. Which one is smaller? I am getting -2 here. So I got the value of A2. So I'll use the value of A2 and find A3. Here what I am going to do, I am going to take the third row and third column fixed. It means all my paths supposed to travel through vertex 3. So this is my third row and third column and I am going to write it as it is. The next step is to write the diagonal as it is. So the diagonal is written here as it is. And is there any infinity here? Yes. The second row, fifth row and first column. So all these things I am going to write here as it is. And the next step is to find the blank spaces here. Now the blank space here is 1, 2. And the 1, 2 value here is 3. If I project it to the fixed row and fixed column, I am getting 8 plus 4. That is 12. 12 and 3. Which one is smaller? I am going to write this value here. The next empty cell is 1, 4. Here I am having 4, and if I project it, I am getting 5 and 8. 8 plus 5 and 4. Which one is smaller? 4. I am going to write it here. And the next empty cell is this one. If I'll see also, I'll get minus 4 as the smallest value. Similarly, the next empty cell is 4, 2. Here also, if I am going to project it, 5 and the sum of 4 minus 5. The sum of these two becomes smaller, minus 1, I am writing here. The next empty cell is 2, 5. And if you are seeing here, minus 2 and sum of 11 and 5. The value I am getting minus 2 as a smaller value. So I got all the empty cell filled and all the values in the A3 matrix got filled. So I am going to take that and find A4. So here I am going to take the 4th row and 4th column as fixed. It means all my path from every pair is going through 4th vertex. So I am going to write here as it is. The next one is diagonal remains the same. So diagonal value I will write here zeros. And is there any infinity over here? There is no infinity. As there is no infinity in the fixed row and fixed column, I am going to fill all the blank spaces now. Here 1, 2 is a blank space. So what I am going to do? I am going to take the value here 3 and I will project it to the fixed row and fixed column. The value I am getting 4 and minus 1. The sum of these 2 and 3. Which one is smaller? I am going to write it here. The next cell is 1, 3. So here the value is 8 and if I will project it, I will get 4 and minus 5. The sum of these 2 and 8. Which one is smaller? Minus 1. I will write it here. The next cell is 1, 5. So if I will project it to the fixed row and fixed column, I am getting 4 and minus 2. And I am having minus 4. If I will take this 2, which one is smaller? Minus 4 is smaller, so I will write it here. The next empty cell is 2, 2. 2, 2 supposed to be 0. If I will calculate also, I will get 0. So no need of calculating this. Next empty cell is 2, 3. That is infinity. Infinity and the projected value I am having is 1 plus minus 5. So the value I am getting is minus 4. I am going to write it here. The next empty cell is 2, 5. So here is the location. The original value is 7 and sum of the projected value, that is 1 and minus 2. These two I will get minus 1. So I am going to write it here. The next empty cell is 3, 1. And in 3, 1 cell originally I am having infinity. And the projected value to the fixed row and fixed column is 2 and 5. The sum of these two and infinity. Which one is smaller? So 7 I am getting smaller value. I am writing here. The next empty cell is 3, 2. And 3, 2 originally I am having 4. And the projected value to the fixed row and fixed column is 5 and minus 1. Which one is smaller? I am getting 4. The next empty cell is 3, 5. So in this manner I am going to take the value one by one and going to write it for all the empty cells. So this is how I am going to get my A4 matrix. So I got my A4 matrix. Now I am going to take my 5th row and 5th column as fixed. It means my path from I to J supposed to pass through the 5th vertex. So if I am going to fix it, I am going to write it as it is. Now the diagonal is supposed to be written as it is. So the diagonal is written as it is. Now you can see there is no infinities here. So all the blank spaces I am going to fill as I filled earlier. Let us check 1, 2. In 1, 2 location I am having 3 and the projected value here is 5 and minus 4. The sum of these two is 1 and 3. The minimum value is 1. I am writing here. The next cell is 1, 3. Here is the cell with value minus 1. I'm going to take the projected value 1 and minus 4, the sum of these two, and minus 1. Which one is smaller? Minus 3 I am getting. Then the cell 1, 4. 1, 4 value originally I am having 4 and the projected value are minus 4 and 6. And the small value I'll get is 2. In the same manner, I'm going to find 2, 1 value. The 2, 1 value I'm having 3 here and the projected values are minus 1 and 8. The sum of these two I'm getting 7, so minimum is 3. The next empty space is 2, 3. 2, 3 I am having minus 4 and the projected value to the fixed row and fixed column is 1 and minus 1. Sum of these two is 0 and minus 4. I am going to take the minimum, so minus 4 I have written. The next empty cell is 2, 4. So 2, 4 value I am having is 1. 6 plus minus 1 and 1. Which one is smaller? I am going to write it here. That is 1. Similarly, 3, 1 value I will be getting 7. 3, 2 value I will be getting 4. 3, 4 value I will be getting 5. Then 4, 1 value I will be getting 2. 2 value I will be getting minus 1. 4, 3 value I will be getting minus 5. Now I got all my cell filled in A5 matrices. I am having 5 vertices. I have gone up to A5. It means all the vertices I have traversed. You can see here, this is the graph given to us and this is A5 I got. Now you can check every pair of vertices. From 1 to 4 there is no direct edge, and from 1 to 4 if I am going, I am having path from 1 to 2, then 2 to 4. So the distance from 1 to 4 via 2 is 4, and there is one more path, 1 to 5 and 5 to 4. 1 to 5 value is minus 4 and 5 to 4 value is 6. Here the sum is 2. So 4 and 2, which one is smallest? The smallest is 2. You can see 1 to 4, the value we got as 2. So any pair if I want to take, I'll be getting the smallest path from this particular table. I hope you understood this. Now let us talk about the formula that we have used. So A0 of Ij is the cost matrix that we got, that is the adjacency matrix. And if we are having a previous table A0, by using A0 I am finding A1. Aij value in the kth matrix I'll find by taking minimum of Ij value in the just previous k-1 matrix and in the previous matrix Ik and Kj. K is the intermediate vertex. So this is the formula that we have used. Now there is a chance that the path may visit through the intermediate vertex or may not visit through the intermediate vertex. If the path is visiting through the intermediate vertex, then this part is coming to play, and if it is not passing through the intermediate vertex, this part is coming to play. So I am going to take the minimum of these two to find the result. Now let us talk about the algorithm. So as it is a matrix, always we are going to take two loops. The cost matrix is nothing but A0. That is the first thing that we did. Next what we did, we have taken the value of Ij and minimum of Ik and Kj. Here there are 3 loops I am having. As there is a K which is changing, so I am taking one more for loop for K. So what I am doing, the original value of Ij and Ik plus Kj's minimum I am taking and writing it here. So you got the algorithm also. Now can you guess what will be the complexity of this all pair shortest path? The complexity will be theta of n cube, where n is the number of vertices in the graph. I hope you understood how to find all pair shortest path by using Warshall-Floyd algorithm. If you understood, give me a like and share among your friends. In our next video, we are going to talk about yet another application of dynamic programming. See you then, take care.